Just like how full-size helicopters had their engine revolution, unmanned aerial vehicles had the same sort of change. The point of them is that they're unmanned, so we can do a lot of new things we couldn't do when we had the intention of putting a person on it.
I have been using this drone for like almost a year for like aerial photography and sometimes for geomodeling. I can see a lot of things I have never seen before because you can see the whole landscape. I'm currently using drone for my capstone research to test it for like historical site conservation in different parts of China, modeling for a really huge site like Great Wall or the Forbidden City. I can use drones to make a model of them by kind of overlapping and consolidating all the image. You kind of creating these geo models by converting 2D pictures into a 3D model. They are cheap, they are affordable, easily accessible, and they're also portable. I mean, everyone can buy a drone on Amazon, eBay nowadays. We see the advancement of technology that drones carry really good cameras.
Unmanned aerial vehicles have been around probably longer, but definitely since the 70s. The military would occasionally put remote flying systems on their fighter planes. Many things have evolved over time, all in parallel. Power plants and the energy storage has gotten smaller and smaller, denser and denser. New ways of generating more lift with less drag. Material advancements, sensors, and computation have gotten way, way smaller and way, way better.
The drones have a really great potential. They are a platform, so you can attach a camera, other like sensors or devices onto it. As long as it can carry it and fly it into the air.
Precision agriculture is still a new field when it comes to observation and monitoring, and that's where robotics comes in and autonomy comes in. If you go back 10 years ago, the kind of data we are talking about, multispectral imagery, hyperspectral imagery, that was only done from satellites. But a lot of the features that you want to look at in plants are like millimeter scale or centimeter scale features which you cannot see in a satellite image. So these are the kind of things UAS will be able to do rapidly. You can fly at an altitude, not at 3,000 feet, but at 100 feet, and get a much better information. The three kinds of data we look at for plant. The closest to impacting the market will be predict how many oranges they're going to get or how many apples. Morphology is to understand plant growth, understanding the geometry of the plant. Health being is the plant disease, is the plant suffering from nutrient deficiency.
We had some drone flights for the last 4 weeks. We want to know if there is a certain amount of plant stress that we are seeing.
That'll save a lot of man hours of just riding around and looking, and then hopefully it also provides us with more early detection before maybe even the naked eye can see.
It was 2011, our first flights at the Raptor nest, that's the Stellar Sea Eagle. That dramatically changed all our field techniques. So instead of climbing, which took about 1 hour, 2 hours, depending on tree, it now takes 3 minutes and generate no disturbance for the birds. As a result, we managed to get all our survey trips within a week, and previously it took months. I also use it for habitat mapping. So in 1980s, I have good pictures of remote Arctic tundra, which I took from conventional helicopter. And I'm curious what really happens to this permafrost underlaid tundra. Take my drone and go to these locations and try to fly it up there. It's kind of amazing to see how much the permafrost has changed. It's not just melting, it's just new deposits, new erosion, which also reflected in bird population.
The city controller had the idea of utilizing drones to do a pilot to get aerial visual inspection of properties in Philadelphia that are unsafe or dangerous. A lot of times properties have roofs that are collapsing that you might not see from the ground level, but with a drone you can get that image. You can tell whether a property is worse than what it looks like from the ground. Also, being able to get to abandoned properties where it might be too dangerous, the drone could capture the video and photographs in a more safe manner. The controller came up with ideas for other city departments and agencies that could use drones. Different cities around the country are utilizing them. Looking at new technology and innovation,
my work is dedicated to finding new vehicles, trying to make them smaller. Small vehicles are more nimble. Also, if you want your robots to work in teams, it's a lot easier to have many small vehicles than to have many big vehicles.
In the next few years, we are going to carry some better cameras. So definitely we are going to see a small drone carry more capacity to carry more stuff.
Yes, it is a powerful tool. Yes, it would be difficult to live without it anymore, but has to be incorporated in something else.
The sensor is the crucial component, but that's what's exciting, is what we can sense and how we can deliver the sensor through the crop and then make our responses based on what we've observed.
My long-term vision is how to make robots not just observers but actors. If the robot has such sensing mechanisms, cameras and a nose, how can the robot use that to lock on to a plant that's of concern and bring back a sample?
We are very new at it. This is, our first season doing it. But I'm hopeful.